Okay. All right. So here we are back again for another talk on AI and the software wave by our very own John Resendez, and we're looking forward to this. So I will turn it over to you, John.
Okay, thank you. All right, so this is round two of this. A few people online and just a couple folks here, but we'll walk through some of these at least concepts and see if anybody has any questions or thoughts as we go through it. So I've got a couple of different little sets of slides that we can use and kind of walk through. One's a little more just a big idea, and then the other one kind of cuts more into the nitty-gritty of ways I approach it and ways to set things up and work through doing agentic software development. I wonder if they'll come up with like angelic software development. Maybe that'd be more interesting. I don't know, but we'll leave it at agentic for now. So thanks for coming out. So this first little presentation I put together, I call it a rock dropped into a still pond is the idea that becomes software. And the idea there is that idea you have of what you want to build is what we're going to build upon. And that's going to create this wave pattern that's going to keep growing and extending out as you work through developing your software and using AI to help you get there. So when you get this wave built up towards the end, that bigger wave that you're creating is going to be your final product that you're going to do. So I'm going to talk about ways to just kind of conceptualize that a little bit. So as I said, let me just update this screen one more time. There we go. So as you can see, this is your idea here. So the wave that I'm showing you is your idea that's starting off as an idea, okay? And then we are going to, that rock hits the pond, and it's going to create its second wave. That little pattern is going to repeat over and over and over as it extends out, as that rock kind of, that wave pattern grows. So the first part of it, after your idea, is the exploration part. And the idea here being that you could explore the work that you want to do. What is your idea? Instead of just going straight to, hey, let's build it. Let's use AI. Let's just totally vibe code this. I've got this idea. Build this cool video game. Go. It's just let it do its thing. See what you get out the other side. You can do that, and maybe something will come out interesting. You won't have anything that you really did about that. So that's probably not going to be what you had in mind. It's not going to be this interactive tool the way you thought it would be, or this cool video game, or whatever the software application you're trying to build. That's probably not going to get you there. That's going to give you whatever the AI came up with based on your prompt. And that's a really simple thing. It doesn't take any real skills to do that. You could do that. Maybe it comes up with something cool. Maybe it won't. I'm not talking about that. What I'm talking about is being able to leverage AI to build your vision, to use the skills you learn going to school here and learning logic and programming and all the technologies, and apply that and use AI as an extra skill set as your utility belt to really help you learn and build something that you couldn't do on your own, or would take a team of people to do on your own. So the first part of this is exploration. And by that, I mean, take your idea, split it apart to every possible way you can think about it. Do not commit to a plan, a design, anything. You may have some very specific ideas of what you're trying to build. That's great. But use this as an opportunity to use AI to say, what are other products like this? What are ways this could go well? What are ways it could go wrong? What are some complicating factors that could make this difficult to do? What do I not know about how to build this tool or this software? Use AI to kind of help fill in all these gaps in ways to think about it. And you don't want it all one-sided. You don't want to say, help me build exactly this. You could do that, and it's going to help you build exactly that. But that may really not be what you really should have accomplished. So you want to use this time to get a good sense of all the possibilities and stay there with the possibilities and play with it and let it kind of permeate in your head a little bit. The second way I like to use this kind of wave pattern metaphor is that wave doesn't just propagate and extend out and become bigger and bigger and bigger till it hits the shore. But a wave pattern, it kind of starts off big. It's like almost an explosion, and then it starts to fade away. It goes into a lull before it goes to the next wave. That lull, that's where it's kind of converged, that entropy state. But what's happening there is you've converged all the information that you just explored is kind of condensed down into something a little more solidified. It's a better idea. You've got some ideas now. You've worked through that exploration and it's kind of solidified as some concepts that you want to work with. That's great. You're ready to go to the next step. So the next step is your plan. And again, blow that plan up. Let that wave pattern take over and say, how am I going to build this plan? I've got some good ideas that I've just, worked through, and I want to build a plan to get there. You are not building a design. You're really just still pretty open about how you want to approach this and let AI help you develop, like, what's the plan? What are the technologies? What are the tools? What are some approaches? What are some interface ideas you have? Put it all out there. What's the experience like of using it? If you're an end user, if you're doing agile development, sometimes you'll hear like you'll create like stories and these things. You put like post-it notes, like this person is going to use the software and this is how they use it, and you kind of walk through it. So you can use some of those kind of ideas of structuring how the software is going to work, what's the interface going to look like. So that's the plan. From the plan, you go to a design. This is where you really you now converged on a plan. Now you're going to converge on a design. And so you explore the idea. What is the specific screens, the processes, the functionality of your program? You start to really work that through as an actual implementation type of plan that you can build off of. So, and again, you're engaging with AI all through these things. I've got another slide I'll show you that kind of talks about what your role versus the AI's role is in different parts of these things a little bit. And I think that's kind of a cool slide. And then it becomes the implementation. If you did a really good plan and a really good design, and if you thought about it and explored all the ideas, by the time it goes to build, you should have something pretty concrete in mind. It should be pretty well thought out, and you shouldn't have a lot of surprises in terms of what actually gets built. If you do, you probably didn't plan it very well or design it very well or think about it completely. So this is where the AI can take over in this process. And that's okay. If you did your homework, then when you give this functionality to Claude or to ChatGPT with Codex or Gemini or whatever tool you want to use, when you get to this step, you kind of have to take a leap of faith a little bit if you're kind of going down this path and see what it can produce. It doesn't mean you shouldn't verify it and look at the code and understand what it did. You should. You absolutely should. But this is kind of where the magic of what a large language model can really excel at if you really design and plan this well. So let's just continue through it. The next one being testing. After you've built this, what did it build? What did it do? Yes, this is where you roll up your sleeves and say, wow, what just happened here? It created all these interfaces. Let's go check it out. Maybe it's amazing. Maybe it's horrible, but you're going to find out right there. So go through it, figure it out, test it, validate it, make sure it's doing all the things you put in your plan and in your more concrete design. Make sure all those things actually happened. So this is kind of an interesting point in this process, in this pipeline. When you test this stuff, if it's not quite right, you can make adjustments. You can ask the AI, hey, see if you can fix this. This didn't quite figure it out quite exactly the way I had in mind. Great, you can do that. And you will. But if you go too far into that pool of trying to fix all these little things, this is an area the AI doesn't do very well at. It'll fix it. It might come up with a fix, but you don't know what it just stepped on and broke in the process. Or did it create, maybe you did a variation of a function call or a method that it did beautifully the first try. What it thought from the specification you came up with from the design, it's totally coherent and looks great. But now you've asked for a variation of that. The AI might not say, hey, let's extend this function call. Maybe I shouldn't have fed 5 parameters to this function. Maybe I should have fed an object that contained all those parameters, and I can make that a little more versatile or something. Who knows? But you'll get down these paths where that code will start to deviate from the original coherent thing that the AI put together the first pass, and starts to become messier and messier and more spaghetti code. And you could have 10 functions that are variations of the exact same thing. And if you're not looking at it and staying on top of it, it'll slip out from under you. And now you've got yourself a mess. And that foundation won't stand. You're going to forever fight the code. And you might be able to get there, but it's going to be a lot of work, and you're going to fight it. You're going to spend way more time fighting that segment of this process than if you went back. You almost are better off in a lot of these cases saying, all right, the implementation didn't work. If you are committing your software, if you're using your Git environment well, and you're making change, you committed a good plan and a good design, and you're ready to go, you may be better off saying, let's go back to where I had this design. There are some fundamental things I didn't have correct. Fix it there. You can go back in time, and you can start from that point, do it again. That's going to give you something better. It doesn't feel good. It feels, I just failed. I came up with this thing. I put all this effort in, and now I'm going to go back and I'm going to do this again. This is kind of the secret sauce of this stuff. Is there's this concept of, fail often, fail early, or whatever. But what this kind of gives you the opportunity is to fail more often and quicker, and learn those lessons that you can't know everything off the bat. You're not going to know exactly how this is going to play out. So this is a journey. This is an experience. It's not vibe coding. Here's my prompt, build this thing. Here's your output, make $1 million. I'm amazing. You can do that. Maybe you get lucky. But as a process, you got to put that work in. You got to be steering. You got to be conducting this thing, and you've got to be in charge of this. And you've got to know how to steer it and work with it. We'll go into it a little more detail as we go. The next one there is documentation, and where I can't get that slider where I want. There it goes. So that's documenting whatever works. So once you've tested it, maybe you've gone through a few revisions, maybe you reverted your plan, maybe you got really close and a couple of little minor tweaks got you there and you didn't have to start over again. Great. Once you're there, you've validated it. It seems to be working real well. You should be documenting it. You should be making sure that, you already were documenting when you were coming up with a plan and a design. There's already documentation, but now you want to document how you tested it, what was validated. Can you prove that all these things are working the way you said it did? You should be having unit tests. You can use the AI to create tests of the software as if users are working on it. So you could use this time to build that kind of testing and documenting, and maybe there needs to be some instructions, some manuals. AI can assist you in doing all that as well. And if all goes great, you come out to the other side and you deploy your code. So that wave pattern went all the way to the shore, and you did this process and you got to the other side. Here's just another variation of it. Looks kind of fun. So all this stuff you're seeing, all these charts and graphs that are kind of cool and visual, this was all built using some code that I wrote. And it can build some really interesting dynamic interfaces to explore an idea. One of the things I've been working on, so I've been working on something for Stan State called Warrior AI. And we're going to start doing some pilots of that soon and start to get rolled out for some different things. It'll do some things like some chat bots for various things. We'll find lots of uses for it. It can have integrations with third-party applications. It can do reporting. It can do all kinds of stuff. But we're being cautious as we kind of move forward to get this rolled out in a clean way. But some of the other things I've been exploring as I've been doing this is, one, how to leverage these tools. How does AI work? How does a large language model work? What's going on under the hood? What is a vector database, a multidimensional set of these vectored numbers? What's going on under the hood? How is it coming up with an answer? What is the relationship between these vectors and these words? And how is it, coming up with these amazing things that it does? And the more you understand that, the more you can see, one, the power of it, but you can also see all the pitfalls and the ways it can go sideways on you really quickly. So it's a tool. It's not a perfect thing. So this has a few slides that kind of talk about some of those things I said. So your idea, your exploration, the plan, design, your implementation, testing, documentation, and deployment. I think that's probably enough for this slide. I'm going to jump over to this one. So this one, I go a little more into details in terms of how do you start doing this work and how do you actually build these things? What tools do you need? How do you start to pull this all together? So, there's any number of, yes.
You left out the most expensive part of software, maintenance.
Absolutely, yeah. So this is the first finish line. So this is everything you think you're going to do as a software developer. But I am always happiest before I have any users of anything I've ever written. That's my happiest, that's my high watermark of joy in terms of being a software developer, is building it, designing it, making it look amazing, thinking I've made the most coolest thing that's ever existed. And then you get users. And now you've got problems. And now you've got to support that thing. So that's a whole other thing. And now you're in it for the long haul. And you go from being a sprinter to being a long distance runner. And that's just a slow burn. And you're gonna have to work through it. You're gonna have to do, maintenance fixes. And maybe every once in a while you're going to get to do a major revision and update, and you're going to get to take all your best thinking and bring this thing forward. And that's the good thing too. The other, thing, and I've been at this about 40 years, building software applications. And every other software developer I ever looked up to, I thought was great. But just almost everybody I've ever talked to who builds software is always like, you build something, you may be good, maybe you've got a lot of skills and wisdom you've built up over the years in terms of ways to program and do things. The second you finish any product or package, you learn so many lessons that without fail, every single time, everyone's going to go, oh, I wish I could start over and do it now that I know how to do this. This is a crazy world now, in that you may have opportunities to start over and do this before you ever do this right. I have rebuilt so many things so many times with AI because I have the luxury to do that. And I'll drive everybody around me insane doing it, but I know where I'm heading, and I know what is an exploration into understanding, and I know, okay, it's time to commit to a real plan. Don't commit to that real plan too early. I do a ton of experiments. I will say, let's try this out. Let's give this an approach. I'll do a little mini thing. It's like, let's experiment with this. Let's see if this interface holds water. Can I test it? Can I validate it? Is this really a good idea? Maybe there's a half dozen ways to approach that. I might even build little interfaces, little mini apps around those ideas and see how they play out. and go, you know what? This original one is really not the best idea. Maybe I got to build this 3, 4, 5 times before you really kind of get a really good structure in place. Like, oh, this is going to be, I can build on this. I can sustain this. you know, it's got some good bones, you know, like you're building a house. So it's real easy to get backed into a corner. When I worked for a music software company for a long time, and the biggest competition, the best music software program I had ever seen was written from a professor from Stanford University, Leland Smith, Dr. Smith. He wrote this program called SCORE, and it was a notation program, and it was wildly complex and incredibly hard to use, but it was brilliant. It actually became PostScript that Adobe used. The language and how he was doing all these spline-based curves for notation, it all kind of evolved. It came out of even FM synthesizers. One of his students built, had this idea for frequency modulation synthesizers, and Yamaha and Synclavier took these tools and into it. So these amazing professors built these tools. And when I couldn't understand this program, I had to do support on it. And I spent a day with him at Stanford in his office, and he never turned on his computer once. He just told stories of his life. He was older and was, you know, he was kind of largely winding down his career, but was not going to let his office go. And you know, it was his thing. This program was his baby. But after spending an entire day with him, everything in this program made sense. The way he thought was just so embedded into the way that thing was written, that if you knew his personality, everything in the program just kind of fell into place, and you just made sense. Anyway, so the company I worked at, we actually licensed his tools and sold it, but we wanted to make something that was more accessible that users could use. So we wrote a program called Encore, and it was cool, and it was very state of the art when it came out, and it was a beautiful music notation program. The lead developer who started it, he was a really good musician. He was not a classically trained musician. He was more of a pop guy. I think he was a guitar player. He did not spend a ton of his, you know, his life reading sheet music. He knew some basics. So he built it based on his understanding of sheet music. And then it's like, oh yeah, it does all these, you know, notes and ties and things. And it's like, how do you do slurs? He's like, slur? What's a slur? It's like, well, it's this line that you draw over the top of the notes, and it groups them all together. And he built all these structures to be able to handle these little subgroups. And now he's got to build this structure that goes over the whole thing. And it's like, my architecture can't handle this. And so it was always kind of a hacked on thing on top. And we fought it forever. That program died with all these quirks of things that we didn't consider off the beginning, that if we had known, we could have solved in a more comprehensive way, and it never would have been an issue. So anyway, just to give you an idea of some of that. Okay, let's talk about a few of these things. And actually, before I go any further, any thoughts or things on any of that, or you just want to keep going? Anybody in the chat? Looks like we're okay. All right, so let's talk about getting going with this. What tools do you need? How do you get these things configured? So you can do this a number of ways. You know, version 1 of this is log into ChatGPT and just use that chatbot conversation, and you can have it write code right there and there. You could copy and you can paste it. You could be writing scripts. If you got some way to compile code, whatever, knock yourself out. You can do that. When I first started, when ChatGPT, whatever it was, 3.5, I think is when I first jumped on, somewhere in there, some 3 version. I was doing that. I was writing tons of code over the years, and I could use it to make, hey, look at this chunk of code. How would you rewrite that? Let me think about what it has. Let me see what I wrote. I don't know. Let's try it. And I'm painstakingly moving chunks of code in, trying it out, not trusting it at all. That's where I started. And I stayed there for a while. But anyway, so you can do it that way, or you can use an IDE, you know, as a software development environment, like something like VS Code or Cursor or Visual Studio or whatever tool you would like to use. You could use TextEdit. You could use Notepad. You could use VI at a terminal prompt if you're hardcore and just want to show people that you could be on a movie set in a movie, type in at a terminal. You could do that. I used Cursor for a long time. One of the things I liked about Cursor was the way they integrated AI into their IDE. And I don't know, what's the number? Integrated development environment or something. But so what I liked about Cursor is they extended what VS Code did, and they added a whole AI panel built into it. And if you bought their subscription through them for Cursor, you got to use the models as part of that subscription fee. So you could use Claude Code, you could use ChatGPT, you could use Gemini, you could use all sorts of them. And they were embedded in the program, and I didn't have to configure it and set it up. It was just there. And I could do it you could do it in different modes. You could do it in ask mode. Ask mode is where you're just having a conversation and say, hey, how would you do this? And it spits something out. It doesn't write anything. It doesn't put it in your code, but it'll spit it out on the screen, and you can do with it what you will. And then there's agentic mode, agent mode. And what that allows you to do, it can not only be looking at your code base. So having it integrated like this, it can look at all your files in your code. Now it can start directly updating that code, where it sits, where it's living, and saving it and updating it. When I found out about this, I don't know, a couple years ago, I was sitting having coffee with my two programmer sons, and they were already starting to explore these things, and hey, Dad, try Cursor. You're gonna love this. And I was like, okay. And one of them said, have you tried agent mode? And I said, agent mode, what's that? and that was a leap. It's like, oh, it just wrote something. What did it do? How did it screw up my code? That was my first thing. And you know what? It was kind of screwing up my code. It really was. And it was like, wow, this is not great. But I could see where this was headed and where it was going and what was possible. So anyway, so I started with Cursor and those integrated tools you can get. You get so much usage out of it. There's limits to how many calls you can make and how many tokens it's using. You can get, extra plans to be able to use that, to extend how many calls you can make and which models and, what level of the model, all that kind of stuff. And I did that for a long time, and it was working well. And I started hearing more and more about Anthropic Claude. I was using ChatGPT at the time mostly. And so I was looking at what Claude did. And there was something about it that just seemed a little more focused around doing coding than the ChatGPT ones, at least at the time. So I started playing more with Claude Code. And I was still doing it in Cursor within their integrated little panel over there. And then Anthropic came out with Claude Code as a separate tool, and it ran in a terminal within your IDE. So instead of using the separate panel here, I was just basically at a command prompt, and you instantiate this little routine, and Claude Code fires up and says, hi, how are you? What do you want to do? And it has access to your code, and I'm just typing in a really fluid conversation back and forth. It outputs things, tells me what it's updating, it's doing all these things. And now it's getting a little more advanced, and they have their own extension. And so you're no need to be in the terminal anymore. It's just kind of its own interface, and you kind of work that way. That's typically what I do now. Every once in a while I'll do something in Cursor, but mostly I've moved over to VS Code. Cursor was actually an extension of VS Code. VS Code was kind of Microsoft's lighter version of Visual Studio, but I think over the long run, VS Code may even just make Visual Studio go away as well, and this becomes maybe more their their kind of premier tool for doing software development. So you need to set up something to do some coding. So I would say VS Code or Cursor. I did like that Cursor gave you some tools right out of the box if you can, do that. So you need that. You need a Git repository. You can just sign up for these things. You don't need to pay for it. You can get a free Git repository. You can set up any number of them. You can make them publicly available. You can make them private. So if you want to share or you're working with other people, you can even share it privately, or you can say, hey, this is open source. I want everybody to have access to what I'm building. We're going to build it as a community. Great. But so you don't have to pay for these things. There are things there's paid for tiers in Git you can do, and there's lots of good reasons to do that. But you can build your own private thing, and it gives you a place to store your code and work with it. Claude and GPTs, all of it can access that Git repository and be writing to it and updating it. So it's updating your local code. It's keeping it synced to your Git repository, and you want to get these things integrated. If we're exploring the opening up the models for OpenAI to make things like Codex available for everybody. We're going to talk about that, I think, tomorrow, maybe next week. I can't remember which meeting is tomorrow. But anyway, one of the AI task force, we're trying to be careful about what things we roll out and how. But I think I'm going to really push that Codex should be completely rolled out for everybody, including students. So we'll see if we can do that. But the idea being with Codex, the CSU is paying for a license for every state-funded student, staff, and faculty within the CSU. So it's an incredible, opportunity to be able to leverage these tools and to use them. So to make Codex work with a VS Code, you need to have Git connected, and then it'll be working against that, and then everything just kind of comes together, and all of a sudden you've got everything ready to go. And so you install Git, you install your LLM, whether it's Codex, whether it's Claude, whether it's Gemini, whatever, you get all these things integrated into that tool and you connect it all together. So this little presentation, I gave it to Dr. Martin, and she can send that off to anybody who wants it. In addition to some of these things, I'll show you some things, but let's just go through it. Like I was saying before, each step of this wave, or each process, each part of this thing, whether it's the idea to exploring it, to planning it, to designing it, implementing it, let that little pattern go over and over. Let that little wave pattern go of explore the possibilities of each step where you are, and then stabilize on a set of answers, and don't move to the next step until you've really stabilized on where you are in that process. Okay, this is one of the things I really wanted to show. I think this is a cool slide, or a cool little graphic. So this is the process again, but when you start off, you've got an idea. This is you. That orange line is you as the software developer. That green line is the AI agents that are going to assist you in building this. So when you start, this is all you. This is where you need to be the brilliance that's coming to the table to come up with an idea. What's your brilliant idea? As you start to explore it, that AI is going to meet you right where you are, and you should be fully leveraging that to help you explore an idea. You need to stay on top of it. It didn't go on top of that line. It's right below it. So you are steering it and exploring it, asking questions, laying it out, structuring it. Maybe you're building a big thought map image of it. You could tell AI, instead of sending it to me as a big narrative, maybe send it to me as a big JSON structure with nested concepts. And maybe I want to throw that into a thought map, and you want to explore it and think about it. Use it as working tools. The next step, when you go to the plan mode, it flips back to being mostly you. This is you've got to really figure out what you want to do. You just explored it. Don't let the AI dictate what you want to make happen. The plan needs to be yours. That's actually the lowest point of what I'm saying you should use AI to do. You design the plan. You can use AI to maybe help you type it up well. It should be your plan. It doesn't have to be your exact words, but it really should be your plan. As we go to the design phase, it's that AI starts to come back up again, which means it's going to be assisting you. It's like, I don't really know exactly how I'm putting this plan together. The AI has all this knowledge and understanding that it can leverage to help get you there. It's going to bridge that gap between your knowledge of where you are and what it can bring to the table. So use it. Let it start to come up, but you're still in control of this. You're still above it. As you start to get ready, as you're building your plan, your ideas, your concrete plan is becoming a design, and all of a sudden you're going to cross over and that AI is going to take over. If you did this well, that's good. Let it do it. When you hit design, when you hit build and execute it, go get some popcorn. Go let it run, see what it does. And let it take over. You kind of take a back seat at that point. But if you did all the hard work, you're at a good place. So let's go to the next one. When you get to testing here, you'll see that it's kind of, now they're just kind of staying even. They've kind of converged on a concept. That means you're in alignment with, the AI is in alignment with your plan, your intentions. If these are wildly divergent, if this AI is coming up over here, maybe you're finding all sorts of problems with the code. If that AI starts taking over again at this point, yeah, you've got all kinds of problems and it's not going to work right. So you're going to have to back up and you're going to have to rethink this a little bit. And then the same with documentation. If you did this well, these last couple steps are in sync with the AI and it's just supporting the work that you're doing. And then finally, you've got your finished product and that's back to you. The rest of these things, I set up all kinds of ways to think about each step of this. And so there's even some prompts of ideas and ways that you could approach asking the AI to assist you through those. There's some examples, talks about how to kind of take it from exploiting the idea out to kind of converging on answers for it. Some of the tools you could use to do that. And I thought this was good too. I created each one of these areas, I gave it a little checklist. So if you run this little interface, you could run this checklist. Like I ran the problem, I explored 3 different ideas, I explored adjacent ideas, just ways to try and break this up and to work through it. This can get, you don't have to use any of this, but at least this gives you some ways that I've kind of come up with. I've actually built tools that do a lot of this work for me so I can work faster. And I've tried to take all the ways I've thought about this and turn that into some tools. And so it kind of does these things for me. I can build a lot of interfaces in a few minutes, which is weird. And I'm very specific and deliberate about how I structure my beginning inputs to it. And there's a couple checkpoints through it that make sure it's staying true to my vision of it. So it's an interesting thing, and I'm happy to kind of show anybody some of that after if anyone wants to see it. Anyway, so I go through all those different things for each one of those areas and give you some ideas and some plans to move through that kind of stuff. I know there might be another thing coming up, so I want to make sure if anybody has any questions or thoughts, jump in. If you want to ask me something one-on-one after, that's fine as well. Happy to talk about it. Happy to show you just random crazy interfaces I'm building. I tried to build a really horrible video game that took Tetris and like Galaxia and build it and combine them into one really bad game. Anyway, that one's out there. What was another one? I don't know if that's going to come together very well. But I've developed a physics engine that takes particles and it reacts to solve a problem and think about it. So I've built all kinds of different interfaces around this idea. But if I started typing and say, hey, just even typing, it starts to react a little bit. My little particles start to go. And if I said, hey, how does this work? It's exploring the idea of how it works and it's thinking about it. So it's like a little neural net that's exploring the possibility space. The first thing it's doing is it's exploring what I just asked. What does that mean? How do I think about this? It's exploding the problem into a bunch of different things. And then it does it a second time. This is all three-dimensional. I can spin it. I can do all kinds of crazy things. These little blobs on the outside, those are the concepts it came up with. And those particles are distributing themselves around these concepts. And that it'll give some answers about how it explored the concept. And then it'll do a second pass at it where it shows of the concept. The first one was what concepts are involved. The second one of those, what's the distribution of how it should answer the problem and come up with an answer. And it finally just said, how does this work? It answered over here. The technical communicator is well suited here because, so technical communicator was one of, this model was based on styles of communication. One of them was technical versus intuitive versus emotional versus all these kinds of ways of kind of styles of communicating or thinking through a problem. That was this engine. I can build any one of these models to do different things. So I'm building a lot of those kinds of things. Where I am now is a little crazier still. Let me see if I can find it. Okay, let's see. This is a spiral cone that represents a way of thinking about how reality works from like a combination of quantum physics, general relativity, but also kind of imagining reality as a spiral cone-shaped structure that everything kind of falls out of, including some of these things. So if I go from this spiral shape, I could see what a wave pattern on this spiral looks like. So there's the wave pattern that I've been talking about. And in quantum physics, you would see that wave pattern play out with particles. And if I click over here, I can burst the particle wave pattern to hit and move around in that detector. And so I'm building like a physics simulator in here. But what I can do with it is not just build a physics simulator. I can use it as a way to store information. I could take the way reality exists and the way conservation of energy defines how structures exist. And I can use it as a way to actually just store information the exact same way. I can use that spiral shape as a way to order the information from very simple things. Take like 0 and 1. That's the rock, that's your core, that's your nucleus. The next thing will be like a byte. And maybe it's 8 bytes, maybe it's 16, whatever it is, 8 bits. That's the next little part of that spiral that's starting to grow out, that Fibonacci pattern. It doesn't have to recreate the 0 and 1. And you already had that. That's your core. So everything's just kind of a pointer to that original thing. You're extending that concept into more complexity, and that spiral is growing and building out. So you can do a lot with that. And so I'm exploring what you can do with that. But that's what I'm doing. because I'm a little nutty. All right, thank you very much.
Yeah, thanks so much. And, adjourn to the courtyard for a little more discussion. If people have questions, I should probably, stop the recording. Thanks to all the folks out there in Zoom land who were here. So I'm going, should I go ahead and,